My name is Dr. Robert James Mitchell, and for 9 years, I was the lead research scientist at Nexus Pharmaceuticals, one of the most respected biotech companies on the East Coast. I wasn't just another lab coat pushing papers. I was the guy who developed 3 of their most successful drugs, including Memorex, a breakthrough Alzheimer's treatment that generated over $2 billion in revenue and gave hope to millions of families worldwide. My specialty was neuropharmacology, specifically targeting cognitive decline in aging populations. It's the kind of work that requires not just scientific knowledge, but patience, intuition, and the ability to see patterns where others see chaos. A single compound might take 5 years to develop, test, and bring to market, and most never make it that far. But when they do work, they change lives. Nexus hired me straight out of my postdoc at Johns Hopkins, where I had published groundbreaking research on neural pathway regeneration. They gave me my own lab, a team of 6 researchers, and the freedom to pursue long-term projects without quarterly pressure from the business side. It was everything a research scientist could want. The lab became my second home. 18-hour days were normal, especially when we were close to a breakthrough. I missed birthdays, holidays, family gatherings, but my wife understood. She was a researcher herself, knew that some discoveries couldn't wait for convenient timing. My first major success came in year 3 with Cognitex, a drug that slowed memory loss in early-stage dementia patients. The clinical trials exceeded every expectation, and the FDA approval process was remarkably smooth. Nexus stock jumped 40% the day we announced the Phase 3 results. But Memorex was my masterpiece. 5 years of research, starting with a hypothesis that everyone said was impossible, that we could actually reverse certain types of neural damage, not just slow its progression. The molecular structure was incredibly complex, requiring a synthesis process that had never been attempted before. I spent 2 years just figuring out how to manufacture it consistently, another year running preliminary tests. When the first clinical trials showed a 60% improvement in cognitive function among patients with moderate Alzheimer's, I knew we had something unprecedented. The FDA fast-tracked approval. Medical journals called it revolutionary. Time magazine put me on their cover as one of the year's most influential people. But more importantly, I got letters from families whose parents, grandparents, spouses had gotten pieces of themselves back that they thought were lost forever. Nexus rewarded my success appropriately. Corner office, significant salary increases, stock options that made me wealthy when Memorex launched. I was named Director of Neurological Research, overseeing not just my lab, but 3 others working on related projects. Then Nexus was acquired by Meridian Health Systems, a massive pharmaceutical conglomerate known more for aggressive marketing than innovative research. The new management arrived in January with fresh ideas about optimizing research efficiency and maximizing return on investment. Dr. Patricia Vance, the new VP of Research and Development, had an MBA from Wharton and a background in pharmaceutical marketing. She had never run a lab, never designed an experiment, never spent years watching compounds fail in testing. Her first company-wide meeting was about streamlining our research pipeline to focus on high-probability revenue generators with accelerated development timelines. We need to think like a business, not an academic institution, she announced to a room full of scientists who had dedicated their careers to solving unsolved problems. Every project needs clear metrics, defined milestones, and projected ROI calculations. I should have seen the writing on the wall. Dr. Vance's first major decision was restructuring our research teams. Instead of allowing senior scientists like me to guide long-term projects, she implemented a committee-based approval system for all research initiatives. Every experiment, every hypothesis, every funding request had to be justified to a panel that included marketing representatives and business analysts. My ongoing research into neural regeneration was deemed too speculative and insufficiently aligned with market demands. A project I had been developing for 2 years, based on promising preliminary results, was terminated because it didn't fit their 18-month development timeline. Instead, I was reassigned to work on minor variations of existing successful drugs, essentially creating new patents for compounds that were nearing the end of their exclusivity periods. It was legal, profitable, and completely against everything I had trained to do as a scientist. The final confrontation came during my annual review. Dr. Vance sat across from me in her sterile office, flanked by Curran Hughes from Human Resources as she delivered her assessment of my performance. "Robert, we appreciate your past contributions, but frankly, your approach to research feels outdated for our current objectives. You're too focused on theoretical possibilities and not enough on practical applications with clear commercial potential." This from a woman who had never published a research paper, never run a clinical trial, never stayed up all night because an unexpected result might be the key to helping thousands of people. "We're looking for researchers who can adapt to our new collaborative framework and embrace data-driven decision-making," she continued. "Data-driven decision-making?" I said. "What do you think clinical trials are?" Her expression tightened. "I'm talking about business data, market analysis, revenue projections, the kind of strategic thinking that turns scientific research into sustainable profit." That's when I realized she fundamentally misunderstood what we did. She saw drug development as a manufacturing process that could be optimized like making widgets. She didn't understand that breakthrough discoveries came from following unexpected leads, pursuing hunches that might not pay off for years, if ever. "Robert, I'm going to be direct. Meridian is moving in a different direction, and we need researchers who are excited about that journey. Your resistance to our new methodologies suggests you might be better suited for an academic environment." The termination was scheduled for the following Friday. They offered a generous severance package, 1 year's salary, extended benefits, and assistance with job placement. In exchange, I would sign a non-compete agreement and confidentiality clauses about all research conducted at Nexus. Dr. Vance emphasized how much they valued my contributions and how difficult this decision was for everyone involved. Curran nodded sympathetically throughout, making supportive comments about my distinguished career and significant legacy. I signed the papers without argument and spent the weekend cleaning out my lab. 9 years of research, hundreds of experiments, thousands of hours of work, all reduced to a few boxes of personal items and backup drives I wasn't supposed to take but did anyway. But here's what Dr. Vance didn't know: the neural regeneration. Research she had terminated was further along than I had let on, much further. I had been deliberately cautious in my progress reports because I knew how revolutionary the implications were and wanted to be absolutely certain before making any claims. The compound I had been developing, NR47, had shown remarkable results in laboratory tests, not just slowing neural degeneration, but actually repairing damaged pathways in ways that conventional medicine said were impossible. I had been preparing for human trials when the project was canceled. More importantly, the research was based on work I had begun during my postdoc before joining Nexus. While they owned the specific compound formulations I had developed in their labs, the underlying theoretical framework belonged to me. 3 days after my termination, I received a call from Dr. Elizabeth Chen, director of the Neurological Research Institute at Stanford Medical School. We had collaborated on several papers over the years, and she had been following my work closely. "Robert, I heard about the changes at Nexus. Are you interested in returning to academic research?" I was. Stanford offered me something Dr. Vance never could: the freedom to pursue important research without quarterly profit pressures. They created a position for me as senior research fellow with my own lab, a team of graduate students, and funding from the National Institutes of Health to continue my neural regeneration work. More importantly, they understood that medical research was about helping people, not just generating revenue. If a breakthrough took 10 years to develop, that was 10 years well spent if it changed lives. Within 3 months of joining Stanford, I had resumed work on NR47, rebuilding my research from memory and the notes I had kept separately from Nexus records. The compound was even more promising than I had realized, and without corporate pressure to rush results, I could explore its full potential. My new team was brilliant, young researchers who were motivated by scientific curiosity rather than business metrics. Together, we refined the synthesis process, expanded the laboratory testing, and prepared comprehensive documentation for FDA review. 8 months after leaving Nexus, I published a paper in the Journal of Neuroscience that sent shockwaves through the medical community. NR47 had successfully regenerated damaged neural pathways in laboratory models, reversing cognitive decline that had previously been considered irreversible. The response was immediate and overwhelming. Research institutions around the world requested collaboration. The NIH increased our funding by 300%. Medical journals called it the most significant neurological breakthrough in decades. More importantly, families affected by Alzheimer's and other neurodegenerative diseases suddenly had hope for treatments that could actually restore lost function, not just slow its decline. Dr. Vance called me the day after the journal article was published. "Robert, I think there may have been a misunderstanding about your departure from Nexus. Perhaps we acted hastily on some decisions. Would you be interested in discussing a return? We've restructured our research division again, and there might be opportunities that would interest you." I let her finish before responding. "Patricia, I appreciate the call, but I'm very happy at Stanford. We have a different philosophy about research here." "What kind of philosophy?" "We believe that scientific discovery matters more than quarterly earnings. That breakthrough treatments require patience, not just efficiency. That some research questions are worth pursuing even if they don't have guaranteed commercial applications." The silence stretched between us. "I understand you're working on neural regeneration again," she said finally. "I'm working on research that could help millions of people. The same research you terminated because it didn't fit your 18-month timeline. Well, I hope you understand that intellectual property agreements protect work developed in your facilities, which this isn't. Patricia, NR47 is based on theoretical foundations I developed years before joining Nexus, using methodologies I created independently. Your lawyers already reviewed this when you tried to claim ownership last month." After we hung up, I sat in my Stanford lab, looking at the molecular diagrams covering the whiteboard, thinking about the path that had led here. Dr. Vance had made a calculated decision that my research was less valuable than developing minor variations of existing drugs. She had been wrong in ways she was only beginning to understand. The mistake wasn't just underestimating my specific project. It was fundamentally misunderstanding what medical research was supposed to accomplish. She thought it was about maximizing return on investment through incremental improvements to existing treatments. But real medical breakthroughs come from pursuing impossible questions, following unexpected leads, and accepting that most hypotheses will fail. You can't optimize discovery the way you optimize manufacturing because discovery is inherently unpredictable. A year later, NR47 entered Phase 1 human trials with FDA approval. The preliminary results exceeded even my most optimistic projections. Patients with moderate cognitive decline showed measurable improvement in memory function within 6 weeks of treatment. Meanwhile, Nexus Pharmaceuticals was struggling under Meridian's management. Their research pipeline had dried up as experienced scientists left for universities or competitors. Stock analysts were questioning their long-term viability without innovative products in development. Dr. Vance had been reassigned to strategic planning, which in corporate speak meant they didn't trust her with actual research decisions anymore. I didn't take any satisfaction in their difficulties. Well, maybe a little. But mostly, I felt grateful for the opportunity to do research the way it should be done. Driven by curiosity, guided by scientific rigor, and motivated by the possibility of helping people. At Stanford, I had built something better than what I'd lost. A research program based on scientific excellence rather than business metrics, discovery rather than optimization. My students knew that when they proposed an ambitious experiment, I would evaluate it on its scientific merit, not its potential profitability. Medical research is supposed to be about understanding disease, developing treatments, and improving human health. Dr. Vance had turned it into a revenue optimization challenge, and she'd learned the hard way that some things can't be optimized. The last I heard, Meridian was quietly selling off Nexus assets, including several research facilities. Turns out that 9 years of institutional knowledge can't be replaced by business analysts and marketing consultants. Sometimes late at night when I'm reviewing experimental data, I think about that conversation with Dr. Vance, about her certainty that research needed to be more business-focused, that my approach was too theoretical, that success required embracing data-driven methodologies. She was right about data-driven research, but she confused financial data with scientific data, market analysis with experimental results. Real medical research is driven by the data that matters: clinical outcomes, molecular interactions, patient responses. The pharmaceutical industry will always need people who understand that behind every drug, every treatment, every breakthrough, there are real patients whose lives hang in the balance. That scientific excellence matters. That scientific excellence matters. That discovery takes time. That some questions are worth pursuing even if the answers can't be guaranteed. Dr. Vance learned that lesson the expensive way. I learned it too, but my education came with the possibility of changing the world. These days, I still work long hours, still pursue ambitious hypotheses, still face the possibility that years of research might lead nowhere. The difference is that now I work for an institution that values what I bring to the table, that understands the connection between scientific freedom and medical breakthroughs. And when young researchers ask me for advice about building a successful career, I tell them what my mentor told me 20 years ago. Follow the science, serve the patients, and never let anyone convince you that discovery is just another business process. It served me well, and it will serve them well too. Science has a way of vindicating good research, even when the people funding it don't understand what they're looking at until it's too late. 2 years later, I was invited to present NR47 research at the International Conference on Neurological Medicine in Geneva. The auditorium was packed with researchers, clinicians, and pharmaceutical executives from around the world. During the Q&A session, a familiar voice asked about the compound's commercial development timeline. It was Dr. Vance, sitting in the back row, looking older and somehow diminished. Dr. Mitchell, your research is remarkable. Have you considered partnering with established pharmaceutical companies for production and distribution? I looked at her for a moment, remembering our last conversation 3 years earlier. We're in discussions with several partners who understand that breakthrough treatments require patience and scientific rigor, I replied. Companies that prioritize patient outcomes over quarterly metrics. After the presentation, she approached me in the hallway. Robert, that was extraordinary work, truly groundbreaking. Thank you, she hesitated, then added, I made a mistake. At Nexus, I didn't understand what we were losing when you left. I nodded but said nothing. The thing is, she continued, I've been learning. Reading research papers, attending conferences like this one. Trying to understand the science instead of just the business. That's good, Patricia. I know it's probably too late, but I wanted you to know that I realize now what research really means. What it takes to develop treatments that actually change lives. As she walked away, I felt something unexpected, not satisfaction or vindication, but a kind of sadness for the time that had been wasted. The research that had been delayed, the patients who might have been helped sooner if people like Patricia had understood from the beginning what scientific discovery really required.